Oh my goodness. All right. So the last section, the derivative of the 6 trig functions. So this is what we're going to do. We're going to make a table. So here, y and dy dx. I also have this in your notes. I think at the beginning of the section I have notes. So what we need to do is we need to compute the derivative of the 6 trig functions. Ultimately, these need to be committed to memory because on the AP exam, unlike other like physics, they give you a note sheet. There's no notes. You gotta know everything. Okay, so some of these we did for homework. Remember you graphed the derivative on your calculator and then you have to guess the derivative. You guys even remember? Like if you were to graph the derivative of sine x, I don't know if that was an example or you did it on your homework. But if you graph the derivative of sine x, you would see this. Ooh. Of course it keeps on going down and then you go, hey, you somebody, huh? You guys remember doing this? Yeah. So here, I drew the graph for you, so what is it? What is it?
Cosine.
Rhymes with cosine.
Cosine.
Cosine, yeah. And then if you graph the derivative of cosine, not graph cosine, the derivative of cosine, you will get something that looks like this. And then negative 1, 2. And then of course it looks like this, and you go, hey, you somebody, huh? Negative sine x. And then I'm pretty sure we did tangent. Oh no, because tangent is kind of hard to do. So you know what? I don't want to derive all 4 of them. So once you know these 2, you can actually derive all 4 of these. I'll just do 2 of them. Let's do tangent. Because if you graph the derivative of tangent, it's not going to look like something you know, that's why. So, well, what is tangent? Sine over cosine. And then since I know the derivative of sine and cosine, how do I compute the derivative of this?
Quotient.
The quotient rule, because it's a quotient. If you have a product, use the product rule. If you have a quotient, use the quotient rule. So the derivative, dy dx, equals low d high. What is di? Just look over there. You gotta memorize these, that's why. Low d high minus high d low. What's the derivative of cosine? Negative sine. All over denominator squared we go. There you go. Okay, but now you gotta simplify it. So if you simplify the top, you get cosine squared x plus sine squared x all over cosine squared x, and then a, you somebody. Rhymes with bun. That's 1. Come on, that's like the one identity you're supposed to know from trigonometry, right? So what is 1 over cosine squared? Secant squared. That's how we remember. The derivative of tangent is secant squared. So if you ever forget it on a quiz, just derive it. But believe me, you wanna commit these to memory. So this is just a short list now, because we're gonna have a bigger list. We're gonna have the inverse trig function. Then we gotta go e to the x, natural log x. We gotta go through all of those. So don't memorize them all at once. Just memorize them as you go. Okay, cotangent. You would do the same thing. Just do cosine over sine, and then use the quotient rule. I'm not gonna derive that one. Anyway, it comes out to negative cosecant squared. It kind of goes in pairs like this. So like if you know one, you can kind of figure out what the other one is. You know, one of them is positive and the other one's negative. Okay, what about secant? Let's do it over here, because we're filming. So if I want to find the derivative of secant, what should I do? Change it to 1 over cosine, and then it's a quotient, so I'm going to use the quotient rule. So dy dx equals low d high. What is d high? What's the derivative of 1? Read it. 0. Low d high minus high d low, negative sine x, all over denominator squared we go. Okay, that's easy. You just gotta simplify this now. So that's 0. So sine x over cosine squared x. Now this is the correct answer, except that's not the way we remember it. Anyway, if you were to graph the derivative of this on your calculator, we don't know what this looks like. And that's why we have to derive it like this. So isn't this the same thing as 1 over cosine times sine over cosine? Right? Okay, and then A, that's secant. And then A, that's tangent. And that's the way we remember it. The derivative of secant x is secant x tangent x. And then if you're following the pattern that is occurring here, what do you think the derivative of cosecant x is going to be? Negative cosecant x cotangent x. Okay, so as you do the problems tonight, try and get these memorized because they have to be in there. Okay, so now that we got this list, now we can do problems. Okay, I'll do some problems that are similar to your homework and then we'll be done. Maybe we can play a game. Maybe. Okay, here. I'm going to have to erase since we're filming. Should we leave this up? Do you guys need this? Okay, let's leave it up. Training wheels. Okay, compute the derivative dy dx. Okay, so how about y equal, I'll make it almost exactly the same as the homework except different. How about x squared cosine x? Well, what do I see here? I see a product, huh? So what should I do? Should I make up my own or should I use the product rule? Okay, very good. You picked the right one. You'd be surprised how many students just make up their own rules. Okay, so how does the product rule work? Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. Negative sine x, that's it. And there's no real nice simplifying here, so I'm not going to even bother. I'm just showing you the product rule. Okay, let's do a problem like C though. Okay, so how about y, okay, that's the first example. Y equal cosecant x all over cosecant x plus cotangent x. Okay, this one I know is going to simplify to something good. Okay, well I see a quotient, again I'm going to use the quotient rule. Low d high. What is d high? Look at the list right there. What is d high? Negative cosecant x cotangent x. So low d high minus high d low. What is the, what? So you have two terms, so you just go term by term, yeah? What's the derivative of this? Negative cosecant x cotangent x. And then what's the derivative of that? Minus cosecant squared x. See, I have them memorized, so you guys got to start somewhere, yeah? All over denominator squared we go. Yeah, there you go. Okay, so on the next quiz, not tomorrow's quiz, but the next quiz, you write this down on your paper, you're going to get 2 out of 4 points. You want the other 2, you got to simplify it using factoring or trig identities or whatever. Well, what should I do in the top? What can I do? Multiply it up? Okay, let's do it. Multiply it up? Okay, so what do we got? Negative cosecant squared x minus cosecant x cotangent squared x. And then if you distribute this one, you're going to get plus cosecant squared x cotangent x plus cosecant cubed x. All over denominator squared we go. Nothing cancels out. You know, well, I'll tell you something. Instead of multiplying it out, first of all, I wouldn't multiply it out. You know why? Because look, there's a cosecant here and a cosecant there. Why not just factor it out? You know what I mean? Factor?
Yeah.
But it's up to you. You either gonna factor sooner or later. Like, who wants to factor this? You gotta do factor by grouping now. Are you guys good at factor by
No.
grouping? Yeah, I didn't think so.
Yeah.
Come on, we're AB, Mr. Park.
So we eat-
So if I see cosecant there and a cosecant there, factor it out. So what's gonna be left then? Negative cotangent times this, right? So what is it gonna be? Negative cosecant x, cotangent x, minus cotangent squared x. Okay, now, if I factor this out, what's gonna be left?
Whatever.
Well, it's a negative, but this negative gotta be distributed, so you're gonna get what? Plus cosecant x, cotangent x, plus cosecant squared x. And then look, hey, these cancel out there. Okay, well then, what about this thing, Mr. Hart? Okay, let's just write what we have so far. Cosecant x times cosecant squared x minus cotangent squared x all over cosecant x plus cotangent x squared. You guys see it? How you can simplify that?
Yes.
How? Hey, is you somebody? Is this somebody or there's nobody? Either this is somebody or nobody. Cosecant squared minus cotangent squared. Huh?
-1.
Negative one or one? Okay, here, look. Here is the identity. Cotangent squared theta plus 1 is equal to cosecant squared theta. That's the identity.
It's negative.
-1.
It's what?
Positive
It's
one.
one.
Positive one.
This is one. See, so again, what's the hardest part of all of this? Simplifying. Yeah, exactly. Everybody can do quotient rule, right? I can teach it to my dog. Low D high, minus high D low, all over denominator, square D low. But my dog, she wouldn't be able to do the algebra and the trig identity. Okay, so that's what you have to look forward to. On the quizzes, I only give problems where, I don't like this kind where it doesn't simplify at all. I only like to do problems where it simplifies to something good. Okay, next problem, you gotta find the second derivative. Okay, I'll do one. How about, okay, I'll do one like B.
So can we assume on the quiz it's gonna simplify nicely?
Oh, you can't assume, but I like to do that. You know what, I'm gonna erase this already. You guys gonna have this memorized already. You know, come on. Yeah, but not only are we AB, we get 5s on the AP exam. So.
Yes, sir.
Okay, so find the second derivative now. Second derivative, so y equals, how about x, well it's x tan x, so how about x secant x? How's that? Find the second derivative. Who knows? I might be putting problems on your next quiz here because I'm just like changing things around. That's how I make the quiz. And I can't remember what I do up here anyway. Okay, so what do I see here? I see a product. So you use the product rule, just don't make up your own. So first derivative, how does product rule work? Derivative of the first, leave the second one alone. Leave the first one alone. And what's the derivative of secant? Do we remember?
Secant, cosecant.
Secant,
It's
tangent.
not very-
Oh, we picked a good one to go over. Okay, now that's just the first derivative. Now we gotta do the second derivative. Okay, now one you don't need to write, so that's easy. The derivative of secant is secant tangent, right? We have that memorized. Yeah, but Mr. Park over here got like 3 things. We never learned how to take the derivative of product of three things, well, I'm gonna teach you now. How does the product rule work for two things? Derivative of the first, leave the second one alone. Then you take the derivative of the second and leave the first one alone. So when you have three or more things, basically you just take terms. So here, this is how you take the derivative, and we're AB, I'm not gonna give you more than three. Okay? Derivative of the first, then you leave the other two alone. Okay, what do you think I'm gonna do next? Derivative of the second one now, what's the derivative of the second one?
Secant x, tangent x.
Secant x, tangent x, leave the other two alone. You just take terms, and then finally, take the derivative of the third one. Okay, look at that thing, secant squared x, and then leave the other two alone.
I don't know.
See, it's the same thing as the product rule for two things, you're just taking terms. So if you had four things, I'm not gonna give you four things, but if you had four things, take the derivative of the first, leave the other three alone. Then you take the derivative of the second, leave the other three alone. Then you take the derivative of the third, leave the other three alone. And finally, take the derivative of the fourth, leave the other three alone. You just take terms. Okay, that's easy enough, but then can we simplify this? I think we can. Hey, look, right here. Gorilla plus gorilla is 2 gorilla. And then, what about here? Look at these two terms.
Or F.
Well, we really can't do anything with that, so let's just go x, secant x tangent squared x plus x secant cubed x. So this one is not that interesting, because all you can do is factor out a secant x, yeah? So if I factor out a secant x, what's left? 2 tan x plus x tangent squared x plus x secant squared x. That one's not that interesting. I doubt I would put that one on the quiz, but you gotta learn like how to use the product rule for more than two things. Okay. Use double angle identities. I think you guys can do that because you guys did good on the speed quiz, yeah? Okay, I'm gonna do a problem like number 7 though. See, this is why we did the review in the beginning, so you guys can work with trigonometry. Okay, number 7, okay, I'll make it just like number 7, except different. F of x, I see a cosine there, I'll change it to a sine. And then I see a sine there, I'll change it to a cosine. And I see a minus, I'll change it to a plus. That's exactly how I make my quizzes. I look at the homework problem, change the sine to a cosine, change a plus to a minus, change a tangent to a cotangent. Okay, so here's the function. It says, at what values of x is there a horizontal tangent line? Now, I have no idea what this graph looks like. It might look like this, but where does it have a horizontal tangent line? Well, what's the slope of a horizontal line? 0. And what tells you the slope? The derivative. So we want to know when is the derivative equal to 0. So all you have to do is take the derivative, set it equal to 0, and then use your trigonometry skills. That's the hard part, Mr. Park. Yeah, well, Mr. Park, how do I take the derivative of this? Well, isn't sine squared the same thing as sine times sine? Yeah. And then we know how to do product rule. Break it down into things that you know how to do. So, using the product rule on this, derivative of the first, leave the second one alone. But as we've learned before, what happens? Look, it's the same thing, so what do you think? Just put a 2. I don't get it. Okay, then don't do that. Derivative of the first, leave the second one alone. Now leave the first one alone, derivative of the second. But then, do you see that they're exactly the same? That's why you have 2 of them. But that's okay, we can wait till the next step to do it. And then what is the derivative of cosine? Negative sine. Okay, and And like I said, there's two of these, so 2 cosine x sine x minus sine x. I want to know when that's equal to 0. Do I know how to solve equations like this? Yes, because we did review. So how do you solve equations? You make one side 0 and you factor the other side. What can be factored out here? A sine. What's going to be left? 2 cosine x minus 1. And when you have something times something equals 0, either this one is 0 or this one is 0, right? So either sine x is 0 or cosine x equals a half. And these are two numbers, these are numbers we're supposed to know for a trig, right? Okay, sine of what angle is 0? Do you guys do the arm thing like this? On the unit circle, sine of what angle is 0?
0 and pi.
Do you guys do this in pre-calc, Mr. Yeh, Mr. Krosky? That's what just, you think of the unit circle and then you just put your arms where the angles are. See, 0, pi, and 2 pi. Cosine of what angle is 1/2? Pi over 3, and what about this? 5 pi over 3. It helps, you know. Okay, but then you know when we get to the next worksheet, tomorrow night's homework, instead of an equal sign, you're going to have like a greater than or a less than sign. What does that mean? You got to make a number line. But I think we should just practice. Because I'm telling you, there's going to come a point, maybe 1 or 2 chapters from now, every single problem you're going to have to make a number line for. So these are the numbers that you put on the number line. Please put them in the correct order. So you have to test 4 regions, and remember, trigonometry, there's no pattern. Yeah, well, Mr. Park, every time we do it, it alternates. Yeah, until I give you one where it doesn't. Okay, so what would be a good number to plug in here? Pi over 6 or pi over 4, take your pick. I'll go with pi over 6. Sine of pi over 6 is 1/2, positive. If you want to write it down or keep track of it in your head. Cosine of pi over 6 is root 3 over 2. What is root 3 over 2 times 2? Root 3 minus 1 is positive. Positive times positive is a positive. What's a good number to plug in here? Pi over 2. Pick a quadrantal angle if you can. Okay, sine of pi over 2 is 1, which is positive. Cosine of pi over 2 is 0. 0 minus 1 is negative. A negative times a negative, no, negative times a positive is a negative. Say it. No, I didn't write it down for you to say it. No, the movie was a negative times a negative equals a positive.
Yeah.
Hopefully we'll get there. Okay, what's a good number to plug in here? 3 pi over 2. Sine of 3 pi over 2 is negative 1, so that's negative. Cosine of 3 pi over 2 is 0. 0 minus 1 is negative. There we go. A negative times a negative equals a positive. Say it. A negative times a negative equals a positive. Why? No, that's just what he said. And then what's a good number to plug in here? 11 pi over 6 or 7 pi over 4. Let's go with 11 pi over 6. Sine of 11 pi over 6 is negative half, so that's negative. Cosine of 11 pi over 6 is root 3 over 2 times 2. Root 3 minus 1 is positive. A negative times a positive equals a negative. See, Mr. Park, it alternates every time. I'm telling you, it doesn't always do that. Anyway, you're going to be doing this on the next quiz, so. Because you got to be good at number lines. And then I just want to see what you're made of when you do number 8. It says, find the coordinates of the point on this graph, right here. So this point, right there. Find the coordinates of that point there where the tangent line is horizontal. See, now we're getting into calculus. This is how we compute maximum and minimum values on a graph. Because look, think about it. Every time there's a maximum, the slope of the tangent line is 0. When there's a minimum point, the slope of the tangent line is 0. So important points on the graph are when the derivative is 0. So we're going to learn this, I don't know if it's next chapter or the chapter after that, but How do we locate all maximum and minimum points? Well, we find out where the derivative is 0, and then we have these tests we can do to figure out if it's a maximum or minimum or neither. Because sometimes the derivative is 0 and you don't get a maximum or a minimum, like this. For example, the y equal x cubed. Looks like this. See, at 0, the slope of the tangent line is 0, but that's neither a maximum or a minimum. So just because the derivative is 0, that doesn't mean you automatically have a maximum or a minimum. That's why we have to do some tests to figure out what it is. Okay, so that's the next homework. It's not difficult at all. You just gotta get used to just the rules: product rule, quotient rule, and then the derivatives of the 6 strict functions. Like I said, the hardest part for you guys is the simplifying. Like number 6, use double angle identities. What does that mean, Mr. Park? Well, here, I'll get you started on it because I don't want you saying, I don't know how to do it. Well, what is the identity for sine 2x? 2 sine x cosine x. So that's a product. Use the product rule. Well, can't I just do this, Mr. Park? If the derivative of sine x is cosine x, then shouldn't the derivative of sine 2x be cosine 2x? And the answer is no, it's not. You can't do that. That doesn't work. So you just have to do the product rule, and then I'm going to let you discover what the answer is. Okay, we are done. So let's just play. In fact, I just made a game last night. Let's play that one.
I agree.